Hi, everyone, and welcome to PyData Global. We are excited to have you join us. Please feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please feel free to post them in the Q&A tab, and we will address them at the end of the session. Now, it is my absolute pleasure to introduce you to the presenter, Benjamin Vincent. Benjamin is the principal data scientist at PyMC Labs. Now, help me provide a warm welcome to Benjamin. Take it over, Ben.
Hi, thanks very much for the intro. And welcome to my talk on climbing the causal ladder for fun and profit. I'm Benjamin Vincent. I had a 15-year career as a faculty member in academia. And in the last roughly 4 years, I made the transition to academia and have been doing a lot of consulting with PyMC Labs, which predominantly focuses on solving like very hard business problems with a focus on Bayesian and causal methods. I'm also an open source contributor, so I contribute to PyMC, which is a Bayesian probabilistic programming language, um, and I contribute to PyMC Marketing, which focuses on marketing and sales analytics, amongst other things. And I'm the core developer of Causal Pi, which allows you to do causal inference in quasi-experimental situations. We're going to be talking about causality, but I'd like to make it tangible. So we have an example that we're going to consider. What we want to do is called latent demand estimation. So let's say you have some historical data of sales of your product over time. And what we can see very prominently is that we have this upper limit, which represents the amount of stock that we might be able to keep in store at any one time. So that gives rise to two particular situations. One is overstock. So if our sales are below the stock levels, in a way that's bad because we could have sold more, but in a way it's good because it allows us to estimate what the demand for the product might be. The second situation that we have is called a stock out. And this is basically when you sell all of the stock that you have on any given day or week. And in a way, that's good because you've sold your entire inventory. But it's bad because maybe you could have sold more. We don't know what the demand is in this situation. So this presents a data science problem. The demand could have been 6, could have been 7, could have been 20, it could have been 1 million, who knows? So that's the basic scenario that we're looking at. And there are a whole bunch of different questions that arise from this. So just to flesh out this example a little bit more, we have two different media channels that represent our kind of marketing efforts. And on the y-axis, we basically have normalized spend. So this is just how much money are we spending on ads of these two different types. One of the important things that will become relevant later is that in our historical data set, we have a period of time where we engaged on a sustained media campaign where spend was consistently high for a period of time. Now, I mentioned stock outs when you sell all of your stock. These things can actually be quite common. So you might be working on small batch production runs of kind of handmade products. You might be doing kind of innovative product experimentation like this snake flavored toothpaste. You don't want to produce too much because maybe the demand isn't high. You could have the opposite problem of massive demand surges could happen for a whole variety of reasons. Maybe your marketing team is absolutely on fire and you have a campaign that goes viral, but you don't have enough product to satisfy the demand. You could also limit the supply of your product purposefully in order to generate a sense of exclusivity and scarcity. You may also want to have limited stock in order to avoid product waste, and that's important not just because of kind of ecological reasons, but because it takes time, money, and effort to produce stuff in the first place. And if you have perishable goods, for example, it's not good to be throwing these away. You may also have very high storage costs depending on the product. They could be uh, very large items, they could be very expensive and require a lot of insurance, for example. So we're basically saying that stockouts are common, they can be common in certain scenarios, but they're also problematic. So in this schematic example, on the x-axis, we have our level of media spend, and on the y-axis, we have the level of demand or sales. So the blue curve represents like the true demand that would be generated from a certain level of media spend. And this follows like a saturating function, which is um, highly prominent in the marketing space because you can pump as much advertising out as you want, but you're going to kind of start hitting the same customer twice, for example, or people will get bored and tune out of your advertising. Now, the problem with stockouts is that rather than observing the true demand, it's going to be squashed, if you like. And so what you're really going to see are these orange dots. And so if you try to fit a function to this that relates the media spend to the demand, you might what you'll really do is you'll fit the relationship between media spend and sales. Whereas what you really want to know in many cases is what is the underlying demand. And so you may get this relationship wrong, and you might underinvest in this advertising channel, for example. But if you go away and kind of read statistics books, you come to the conclusion that, there's a thing called censored regression, sometimes called Tobit regression, and this will solve many of your problems, you hope. So now um, your kind of estimate of demand, even though you're working off of sales data, your estimate of demand is much closer to reality. So this is great. We've got a problem, and we think that we've got the potential to solve it with censored regression. But before we might dive in and build a solution to try and kind of address this, we might ask what other kind of business insights we want. So we might ask, can we forecast based on previous observations? It's very important to be able to forecast what future demand might be in order to get inventory levels right. You might also want to know how much did last quarter's marketing campaign drive up demand? Another one might be what is the relationship between media spend and demand? So similar to the slide that I just showed. And can we forecast what will happen in the future if we run another media campaign? So your data science team have a go at these questions, and over time, what they find is that the two questions on the left, they can answer satisfactorily, and that's great. But the two questions on the right, um, they find problematic. They might not know how to even answer these questions, or if they get really creative, they might be able to come up with an answer. But over time, they might find that the answer to the questions aren't very accurate, and it can't underpin kind of successful business decisions. And the reason for this is because these questions correspond to different steps of Pearl's causal ladder. So this is a kind of categorization of types of questions that require different types of approaches uh, proposed by Judea Pearl. Now, if you take a purely statistical approach, a bit like our censored regression that I showed earlier, um, you can maybe solve problems caused by stock out, and you can maybe accurately estimate the relationship between media spend and demand. You might be able to accurately forecast what might happen in the future. But if you want to forecast what might happen if you run a different media campaign with different levels of advertising spend, what you're doing is you're making an intervention in a system. You're moving away from pure observation into action. And the causal inference research has shown that in many cases, this will fundamentally change the system that you've been observing, and so you might not be able to make good forecasts. The other question here, how much how much did last quarter's marketing campaign drive up demand? Um, well, this might sound a bit easier because it's kind of retrospective, um, but it's also quite kind of complicated and involves counterfactuals because you're asking a question about something that could have happened in the past but didn't. Um, and so these two questions, step two and step three, require causal thinking. And what I'm going to hopefully demonstrate in the rest of the talk is that when you take a causal thinking approach and maybe build structural causal models, then you can answer um, questions from step one, step two, and step three. And so this is appealing to learn about causal thinking and structural causal models. So let's take our problem and build a structural causal model. What we might do is we might speak to people with business knowledge and come up with a couple of examples, and maybe this is what we do. So we might have an aspect of this diagram. This is often called a graph or a directed acyclic graph, also known as a data generating process, where we think that our media spend and seasonality and certain trend components are causally influencing demand. Another aspect of the model basically states that the sales that we observe is causally influenced by both the demand and the stock level. So at the moment, this is quite an abstract model, but we can make it into a very powerful structural causal model if we describe the relationships between all of these nodes. And just to briefly say, this is not meant to be a state-of-the-art demand estimation model. There are many additional things that we could do, but for a talk like this, we want to keep it nice and simple. So if we want to flesh out the relationships between all of these variables, we can do that. And if we break this down, it's relatively easy. So we can basically say that demand is some kind of linear weighted combination of all the different drivers, be they media spend, seasonality, trend components, and so on. But as we saw before, just very briefly, we have this kind of saturating nonlinear function that relates media spend and demand. So you spend more money, but the amount of demand won't go up proportionally, it will saturate. So we can capture that with some nonlinear functions. And what we can do is not just make a structural causal model, but we can make a Bayesian structural causal model pretty simply by looking at the parameters in the model and placing prior distributions over them. And in this talk, it's not really kind of important what they are. Don't quite have time to kind of go into how you might go about that, but it's a very useful process where you can basically utilize your business knowledge and place that into the model. And finally, the last component here, we're basically saying that we know that sales are causally influenced by demand and stock levels. So in normal situations where you have enough stock, you could say that the true underlying demand might be normally distributed. Sorry, the level of sales that you observe might be normally distributed around the level of demand. However, we know that stockouts occur, and the way that you deal with that is by using a censored normal distribution. And this is, if you haven't heard about censored distributions, this is a very nice little trick in the toolbox, in the statistical toolbox that you can use when you have kind of censoring, like stockouts is an example of that. Now, okay, code. What we can do, you're not necessarily meant to read every single line of this, but this slide demonstrates that what we can do is use PyMC, free open source Python probabilistic programming language to basically write down the model. And so there are components of data, there are components of prior belief, media transformations, and then we have our kind of core model of demand, which is kind of a linear weighted sum of all the different drivers, and then our censored distribution. So it's not a very high effort thing to do in order to create a structural causal model in Python. And one of the important things is that when we build a model like this, it actually has a symbolic structural causal model kind of representation. And we can see that by calling this plot function on the model. And it looks a bit complicated because it additionally has our unknown parameters. But if we gray those out, we can see that the model that we've built is basically exactly mirrors the one that we intended to, in that we have media spend, trends, and seasonality influencing demand, and we have sales causally influenced by demand and stock level. So this is great. The next step is to basically fit the model. So we're going to use PyMC's do operator, and unfortunately I don't have a lot of time to kind of explain about exactly what this is, but this basically is us coming along and providing or stating or intervening that this is what we observe. And so we have our initial model, which started off kind of empty, if you like, and we're basically providing it with all our exogenous observed variables. And that includes the sales as well. And then we can run a couple of commands in order to basically do the fitting. And at the end of the day, we get fit results, which we can visualize like this. So the plot at the top shows the true sales as the black data points, the predicted sales with Bayesian credible intervals are shown by the orange band, and we can see that the model is well capable of predicting the sales. So that's a good validation check. But what we can also do is we can plot the model's inferred latent demand. So this is really powerful. And so far, we're still in kind of statistics land, reaping the dividends of censored regression. So you can see that in situations where we have stockouts, we are estimating what the demand may be. So this is very useful. And practical use case, what we can do is basically add up all of the lost sales due to the stockouts, and we have full posterior distributions, and so we can say with a certain level of confidence that between 20 and 35 sales were lost due to stockouts. We can also say that somewhere between 145 and 169 items were wasted because they perish if you don't sell them fast enough, were wasted due to overstock. Now, if you plug in the how much you sell these items for and how much they cost to produce, you can calculate how much revenue that we've lost and how much investment we've maybe wasted. And that's kind of exciting and compelling because we can start to think about profit optimization by running through different scenarios here um, and playing with demand and supply management. So that's really cool. So now what we're going to do is to step onto Pearl's causal ladder, and we've got a couple of examples. I'll just illustrate the basic workflow here. We're again using the do operator, which is a very important causal concept. And this allows us to take our model, including what we've learnt from historical data, and to consider an intervention. And in this particular case, we're going to consider periods into the future. And that can be challenging because we might know something about the future, like seasonality, for example, but we maybe don't know exactly what the marketing department is going to do in terms of their spend. And so we have to make a call and say, what scenario are we going to evaluate? And we're going to assume that the media spend proceeds along at the kind of historical average level. And this is, as you'll see, a simplification. But we can provide the model and our kind of intervention scenario to the do operator, and we get a new model, and we can generate predictions from that model. And these are visualized on the right hand side. So on the left, we have our historical data and model fits. And on the right, we have our forecasts. And in red, we've got the forecast demand, which has an element of seasonality, which is kind of interesting. And in orange, we have the sales. And so what we can say is in a business as usual scenario, we're going to end up seeing lots of stock outs, basically. So this might prompt us to think about doing something. So that then raises the question of, well, what will happen if we increase stock levels? And this is where we go beyond what we can do with raw statistics, and now we really require causal thinking. So now our intervention will essentially say, what do we believe will happen in the future if we elevate our stock levels? And we go through the same procedure. And now what we can see compared to our historic stockout level, we can see that demand basically is the same as before. There's seasonality and there's some growing trend, which is really great. But by increasing the stock levels, we are seeing much less stock out, and so you can do the same thing and do your calculations of revenue and profit and so on. The final step on the ladder. So if you remember from our kind of scenario, in our historical data, we have a period of time where we had a marketing campaign of elevated, sustained marketing spend. And what we can do is ask what was the causal influence of that marketing campaign? we spent money on it. We want to know how many additional sales did it get, did it generate? And we can work that out by comparing what we saw to a counterfactual scenario of what happened if we just had like routine market spend. So you go to your marketing spend and your marketing department, and you ask them, what was your planned spend if you had not have done this campaign, and they give you an Excel spreadsheet, and so you pop this in your counterfactual scenario, uh, generate a new model which will allow you to kind of make predictions in that new scenario, and you can do the same exercise. So this is a bit of a busy graph, but the important thing is that in the marketing campaign period around here, what we can see is if we had not run the campaign, we predict lower levels of demand. So that's intuitive, but we've also got quantitative predictions. If we look at the difference between um, the uh, the actual demands that we estimated and the counterfactual demands, we can basically get the causal impact of our marketing campaign. Now, this is a little bit detailed. It's on a daily level. We maybe don't care. We maybe just want to know, like, what's the take-home figure? What was the total number of sales that we got? And we can see, somewhere between 20 and 30 additional sales were causally generated by this marketing campaign. And based on that, you can calculate your return on investment, for example, and either feel good about that or not. So, I've given you a whirlwind tour of Pearl's causal ladder, and at a really high level, we could present a summary like someone sitting at the bottom before they have started their causal journey might think, "Oh, I'm sad because I'm restricted to level one questions, and my boss wants to ask all these other questions that provide a lot of causal value, and I don't know what to do." And so the causal ladder is very useful in helping one transition from statistical to causal thinking. And from this perspective, each step on the causal ladder seems categorically different, because it involves different degrees of causal thinking. However, I mean, I just showed you examples of evaluating questions from step one, step two, step three, all with basically the same recipe. All you needed was a structural causal model that fully describe how your variables causally interact. And this is really powerful because it allows you to explore all levels of Pearl's causal ladder, which means you can answer all the kind of important causal counterfactual questions that might be posed and might have very high business value. And so, from this perspective, it's not that each step on the causal ladder is fundamentally different, but the thing that you are doing differently is essentially querying your structural causal model in different ways so as to get the answer that you want. And we think that the Bayesian element has really appealing properties. So thank you very much. And I don't know if we have time for any questions, but thank you for coming.
Thank you so much, Benjamin, for your presentation. For the sake of time, I do think we have to wrap up the presentation now. But as it says on the screen, if you have any questions, feel free to reach out to Benjamin on LinkedIn, or you can use our PyData Discord, where the link is available in the reception area. There will be a recording of this session available immediately after. Benjamin, if you would like to share the slide deck, we do have a resources tab on your right-hand side, where you can leave leave that slide deck, and people accessing the recording can also use the slide deck as they go. And for those who are interested in more casual conversations, the lounge is open in the reception area for those small group discussions. But again, thank you so much, Benjamin, for your time and for your presentation. And we're going to go ahead and end the session.